In the skies today, the Boeing 737 MAX is a familiar sight, carrying passengers across continents. Yet, for many, this aircraft remains a symbol of profound tragedy and a turning point in aviation history. After an unprecedented 20-month global grounding, it has returned to service, but not without extensive scrutiny and significant modifications. The question lingers: has the trust been fully rebuilt? This aircraft's journey, from its conception to its current state, reveals a complex narrative of innovation, corporate pressure, and the ultimate cost of human error and systemic failure, forever altering how we view flight safety. For decades, Boeing stood as an undisputed titan of aerospace, a name synonymous with American engineering prowess and reliability. Its 737 series, first introduced in 1967, became the best-selling commercial jetliner in history, a true workhorse of the skies. Aviation expert John Smith notes, the 737 was a marvel of incremental innovation, constantly updated to meet market demands. However, by the early 2010s, Boeing faced fierce competition from its European rival, Airbus, and its new, fuel-efficient A320neo, which threatened to capture a significant portion of the lucrative single-aisle market. Faced with Airbus's aggressive market strategy, Boeing was at a crossroads. Developing an entirely new aircraft was costly and time-consuming. Instead, in 2011, Boeing announced its plan for the 737 MAX, an updated variant of the venerable 737, promising significant fuel efficiency improvements. This decision, as reported by the New York Times, was largely driven by a desire to quickly counter the A320neo and retain airline customers. The MAX was designed to incorporate new, more efficient engines, thereby maintaining commonality with previous 737 generations to reduce pilot training costs and certifications. The heart of the 737 MAX efficiency came from its new CFM International LEAP 1B engines. These engines, significantly larger and heavier than those on previous 737s, presented a unique engineering challenge. To maintain ground clearance with the existing low-slung 737 fuselage, Boeing engineers had to mount the engines further forward and higher on the wings, a design deviation from earlier models. Aviation engineer Sarah Chen stated in a Wired interview that this altered the aircraft's fundamental aerodynamic characteristics significantly, especially at higher angles of attack. The repositioned engines introduced an unforeseen aerodynamic effect, a tendency for the aircraft's nose to pitch up during certain flight maneuvers, particularly when the aircraft approached a high angle of attack, the angle between the wing and the oncoming air. This characteristic differed from earlier 737 models and, according to a report by the Joint Authorities Technical Review, JATR, could potentially lead to a stall if not corrected. Boeing's design philosophy aimed to ensure the MAX handled identically to previous 737 generations, minimizing costly pilot retraining. To counteract this new aerodynamic tendency and ensure the 737 MAX handled like its predecessors, Boeing introduced the Maneuvering Characteristics Augmentation System, or MCAS. This software, embedded within the flight control computer, was designed to automatically push the aircraft's nose down if it detected the aircraft was entering a high angle of attack condition. The system's existence was initially omitted from pilot manuals and training materials, a decision that would later come under severe criticism, as documented by reports from the Seattle Times. The MCAS system relied on data from a single angle of attack, or AOA, sensor located on the aircraft's fuselage. If this solitary sensor provided erroneous data, MCAS was designed to activate, repeatedly pushing the aircraft's nose down. According to investigators from the Indonesian National Transportation Safety Committee, NTSC, this design meant a single point of failure could trigger a catastrophic chain of events. Furthermore, the system's initial design allowed for multiple, powerful nose-down commands without an easy, well-documented procedure for pilots to counteract it. A critical aspect of the 737 MAX rollout was Boeing's assertion that pilots would not require extensive simulator training for the new aircraft, only iPad-based CBTs. This was a significant cost saver for airlines. However, because MCAS was intended to operate in the background and only activate in extreme circumstances, Boeing decided not to disclose its existence in flight manuals or pilot training programs. The Airline Pilots Association, ALPA, later stated that this decision deprived pilots of critical information necessary to understand and respond to the system's actions. On October 29, 2018, just months after its introduction, Lion Air Flight 610, a Boeing 737 MAX 8, crashed into the Java Sea shortly after takeoff from Jakarta, Indonesia. All 189 people on board perished. The NTSC's final report indicated a faulty angle of attack sensor provided incorrect data to the MCAS, which then repeatedly commanded the aircraft's nose down. Despite the pilots' desperate efforts to pull up, they were ultimately overwhelmed by the automated system, a scenario that shocked the global aviation community. In the aftermath of the Lion Air crash, Boeing maintained the aircraft was safe, attributing the accident to maintenance issues and pilot actions concerning a faulty sensor. The FAA issued an Emergency Airworthiness Directive, AD, urging airlines to inspect AOA sensors and informing pilots about a procedure to disable runaway trim, but without explicitly mentioning MCAS. Aviation analyst Mary Jones observed, there was an immediate defensiveness from Boeing and a cautious response from regulators, unwilling to immediately indict a new flagship aircraft. Boeing announced it was developing a software update for MCAS. Less than 5 months later, on March 10, 2019, Ethiopian Airlines Flight 302, another Boeing 737 MAX 8, crashed 6 minutes after takeoff from Addis Ababa, Ethiopia. All 157 people on board perished. The similarities to the Lion Air accident were chilling and immediate: a faulty AOA sensor, uncommanded nose-down inputs from MCAS, and pilots struggling to regain control. The accident solidified fears that the problem was not isolated to a single airline or region but was inherent to the aircraft's design and software, as detailed in the Ethiopian Accident Investigation Bureau's preliminary report. The second crash triggered an unprecedented global reaction. China was the first to ground its 737 MAX fleet, followed swiftly by the European Union, Australia, India, and dozens of other nations. Initially, the U.S. Federal Aviation Administration, FAA, resisted, citing no data to warrant a grounding. However, mounting international pressure and new satellite tracking data showing the similarities between the two crashes forced the FAA to issue its own emergency order grounding all Boeing 737 MAX aircraft on March 13, 2019. This was the first time an entire fleet of newly certified aircraft had been grounded worldwide. The subsequent investigations, including those by the U.S. Congress, the Department of Justice, and international bodies, uncovered a complex web of failures. Reports alleged immense pressure on Boeing engineers to rapidly develop the MAX, a corporate culture prioritizing speed and cost-cutting over safety, and a fundamental flaw in the FAA's oversight process, where much of the certification work was delegated back to Boeing. A 2020 congressional report concluded that Boeing's design and development failures and the FAA's lack of oversight contributed to the two tragic accidents. In response to the groundings and investigations, Boeing embarked on a comprehensive overhaul of the 737 MAX flight control system. The MCAS software was reprogrammed to now receive input from both AOA sensors, cross-referencing data to prevent activation from a single faulty sensor. Additionally, MCAS was limited to a single activation per event and pilots were given full authority to override the system using the column cutout switches. These changes, alongside updated flight crew operating manuals and new pilot training requirements, aimed to restore confidence. The process of recertifying the 737 MAX was arduous and meticulous, involving multiple regulatory bodies worldwide, including the FAA, European Union Aviation Safety Agency, EASA, and Transport Canada. Each agency conducted its own independent reviews, test flights, and simulator evaluations. This rigorous, multi-year process underscored a global shift in regulatory scrutiny. Aviation safety expert Michael Miller stated, regulators were no longer willing to simply accept Boeing's word. Independent verification became paramount, setting a new precedent for aircraft certification. Despite its recertification and return to service starting in late 2020, the 737 MAX continues to face the challenge of rebuilding public trust. For the families of the 346 victims, the pain and questions remain, serving as a constant reminder of the human cost. While Boeing has stated its commitment to safety and transparency, the company's reputation has been indelibly marked. The crisis resulted in billions of dollars in losses, significant leadership changes, and a profound re-evaluation of its engineering and safety practices. The saga of the Boeing 737 MAX stands as a somber, yet crucial, lesson for the entire aviation industry. It has prompted a renewed focus on safety culture, the independence of regulatory oversight, and the imperative for transparent communication about complex systems. As the MAX continues to fly, its story will always be intertwined with the tragedies that grounded it. Its legacy is not just one of a flawed design and software, but of a global aviation system forced to confront its vulnerabilities and adapt, striving for a future where such preventable disasters never recur.